Hello, Isuru Fernando here, SAP Integration Architect. Welcome to my channel. In this channel, I try to break down SAP S/4HANA technical concepts and SAP integration concept into practical learnings. Let's dive into today's topic. So today I want to talk about idempotency concept when it comes to system integration, especially regarding the idempotent process call in SAP Integration Suite. So first of all, let's look at the concept of idempotency when it comes to system integration. First of all, how do you pronounce it? So you might hear idempotency or idempotency. So both ways are used commonly. So you can use either way you are comfortable. So what is the definition of idempotency? So idempotency means an operation can be repeated multiple times without changing the results after the first execution. So just the definition might not make a whole lot of sense. So let's look at this scenario. So let's look at the scenario where we have a e-com portal, a sender system sending sales orders to a backend ERP system. So it can be a ERP system, it can be application, and the orders that are created in the e-com portal are saved in the backend application or the ERP system, which is the message receiver system. So the e-com portal send a request with the sales order and that get saved in the backend database. Then once it's saved, the message receiver system, now the ERP system, send a response back to the message sender. So the message receiver send an acknowledgement back to the sender system. In the happy flow of this integration, you have a sales order request coming in with the sales order information that gets saved in the backend database, and sender receives an acknowledgement back regarding the order that was saved. But when it comes to system integration, we cannot just think about the happy flow. What if the acknowledgement right here never received by the message sender? So this can happen due to glitchy networks when it's the peak time and when you have a low bandwidth network, or simply when the system is down, something happens, the response never reaches the message sender, in this case the e-com portal. But the order was actually saved in the database. So in essence, the sales order was actually created in the backend, but the acknowledgement never got to the message sender. In such cases where this acknowledgement or the response does not reach the message sender, the message sender might think the order was not created. So imagine a user in the e-com portal does not receive what happened to the order and start clicking the order submit button again and again. Multiple requests of the same order can come through, right? And what if multiple requests gets through and create multiple orders in the backend database? User wanted to place one order in the system, but now we have created multiple orders in the backend system. Now imagine, now we start shipping these orders, right? And of course, charging the customer multiple times. So this will be a disastrous situation, right? So we need to avoid such incidents. So this is where idempotency principle comes into picture. So that means API operation can be repeated multiple times without changing the result after the first execution. Even if we get the request multiple times, and if we know that that order was already created in the system, we are ignoring rest of the request. That means we are not changing the results in the backend database after the first successful execution of the operation. So in this case, the operation is creating a sales order in the backend system. So after the first successful creation of the order, even if we get duplicate requests, we are not changing the results, or we are not creating orders again and again. So that is the concept of idempotency. So if we put it into simpler terms, we can think about idempotency in system integration as avoiding duplicate requests. So for a specific sales order number, let's say sales order number 0010, of course, should be created only once in the backend database. Any other duplicate requests for the same sales order number should be ignored. Now that we understand the concept of idempotency, let's talk about which HTTP methods are idempotent. So let's first check the get method. So imagine this request is to get the sales order information from the backend database. Let's say in the request, we send the unique order number and we want to fetch the details of that order back to the sender system. So in such cases, even if the same request for the same sales order number comes in multiple times to the backend database, we are not changing the results in the backend database, right? So we are not updating or inserting any records. We are just reading the entries or reading the database table for the sales order information and sending it back to the requester. So in that sense, we are not changing the result even if the operation is repeated multiple times. So sticking to the definition, get method does not change the result in the backend database even if the operation is repeated multiple times. So that means get method is actually a idempotent method. So what about the post method? Let's say now the request is to actually create a sales order. We use the post method when we want to create a new resource. In this instance, when we want to create a new sales order, we might use the post method and we'll send the request. The eCop portal send the request with the post method to create the new sales order. So in the first instance, the order gets created and we send the acknowledgement back to the sender. What if the request comes in again and again? And we are creating multiple orders in the system. So in that sense, with each iteration, with each operation, we are creating new entries or new orders in the system. That means the post method itself is not an idempotent method because we are changing the results after each and every request. So how about the delete method? Let's say now the request is to delete this sales order number 0010. So in the first iteration, you send a request to delete the sales order and it gets deleted from the backend database. So what if another request comes in to delete the same order? In the backend, the order is already deleted. So the results or the backend database does not change with the next request. The order is already deleted, and even if you execute it multiple times, this delete request for the same sales order, the backend database results does not change. So that means only the first iteration of the delete method changes the results in the database. That means delete operation is also a idempotent method. And patch, similar to post, is a non-idempotent method because patch also can create new instances in the backend. Now that we understand the concept of idempotency as well as we saw the difference between idempotent versus non-idempotent HTTP methods, let's understand the behavior of a idempotent receiver. So now imagine this order receiver itself has a piece of code to check for duplicate request. Now we send the order ID 00010. And before this order is created in the database, what this duplicate check does is check if the order was already created in the database before. If that's the case, it will reject that request. So essentially, we are doing a duplicate check before changing the results in the database. So even if the same request comes in for the same order multiple times, the duplicate check can detect these duplicate requests and reject them. For example, systems like SAP S4HANA, you can implement a piece of code to do this duplicate check based on this unique order ID and reject rest of the requests coming in for the same order ID. So the receiver only creates the order once in the system. Rest of the duplicates are ignored. These kind of systems who can identify duplicate requests and does not change the results in the backend database, right? After the first successful iteration are called idempotent receiver. So not all message receivers or applications are idempotent receivers. Some of the applications cannot identify these kind of duplicate requests. So in that case, we have to bring this logic of removing the duplicates or ignoring the duplicate requests to our middleware. Because the receiver system cannot identify duplicates, we have to bring the logic of identifying duplicates to the middleware. This is where this Idempotent Process Call in SAP Integration Suite comes into picture. Imagine your middleware is now SAP Integration Suite and you want to identify these duplicate requests for the same order coming in and ignore those duplicates. Now in SAP Integration Suite, we'll create iFlow that can identify these duplicates and ignore them. We will use the same example where we send order information to a receiver. Imagine this is the XML message format sent by the message sender. In our case, the ecom portal. So we have some order information here, and most importantly, we have the unique order ID. Each order should be created in the receiver system. And here is the message receiver. So I have created this webhook. You can also use this app. It's called Bceptor. I have created this webhook that listens to requests coming in. So I have a resource called create order. And if you go here and you will notice soon as an order comes in using the post method, it will accept the order and send a response back. Here's the response body. Send a response back saying order was created. So in that sense, this receiver is not an idempotent receiver. It does not check whether the order is unique, whether it was created before. It just accepts every request comes in and creates the order. So that means we have to make sure in our API or in our integration flow, we handle duplicate orders. If the request comes in to create the same order, we should ignore it. So I have created an endpoint called create order. So the first step is for us to get this unique order ID from the incoming message. For that, I will use a content modifier and extract the information from a XPath expression. So let's have a exchange property, and using a XPath expression, we'll get the order ID. So the name of the element is order ID. Using this kind of XPath expression, we can get the value of the order ID. Now the next step is for us to identify whether this order ID is a duplicate or not. This is where we will use a idempotent process call. If you go to the processing tab, you will notice that we need a local integration process as well as a message ID. Here the message ID is the unique identifier of each request that is coming in. In our case, it is the order ID, but it can be any other technical unique ID as well. Maybe like a UUID or a GUID created by the adapter, or maybe like a file name. So it can be any unique ID to identify each request uniquely in the integration flow. So we created an exchange property to hold our unique order ID. So we have our unique ID in this exchange property called order ID. That is what we'll configure here. So that is the message ID. Let's model our local integration process. So the local integration process, you can select from here. This is where I will send the message, if it's not a duplicate, to the receiver. So to send a message to an external application, you can use a request reply step. Let's call it send order, and let's have a receiver as well. Let's call this webhook. Right. Now we configure the connection. Let's add a HTTP connection. And in the connection tab, we have to provide the address of our receiver. So the address we can copy from here, and at the end, it should be create order. And here, I don't need any authentication. I will disable this. We'll use the post method. And that's it for the local integration process. So as you notice, local integration process is the actual process that send the message to the receiver. Let's go back to the process and select the local integration process. Let's save it. Now here, if you notice in the processing tab, you have this option, skip process call for duplicates. So that means if this idempotent process call, when a message comes in, identifies it as a duplicate order, it will not call the local integration process. So that is how we avoid sending duplicate orders to the receiver. So if it's not a duplicate, it will go to the local integration process and send the order. If it's a duplicate, it will skip the process call. Then the message will not go to the webhook or to the receiver. Now let's deploy it. Let's activate the trace as well. Now let's send an order ID 10250. Now it's a unique order. So this order we have never sent before. Now let's send it. Right. Now we get the response from the message receiver saying order was created. Now if you go back to our messages and if you see the trace, you will notice the behavior. So the message comes in, goes to the local integration process, and message is sent to the webhook. If I go to our message receiver also, you will notice now we have one incoming message. That's the order ID 10250. What if we send the same order ID now again? And let's go back to our receiver and see if we have got the order. And you will notice we don't have that order coming into the receiver. The middleware has ignored that duplicate. So if you go here again to the trace, this is the duplicate message. So the message comes in. Because it's a duplicate, the local integration process is not triggered. Now the message does not go to the receiver. So that is how the idempotent process call works with these basic settings. So you can trigger many times, doesn't matter. Message does not go to the receiver as expected. So we tested this out with this skip process call for duplicates activated. But if you deactivate this, you will notice that the message is actually get delivered even if it's a duplicate. So when you don't select this option, what happens is even if the idempotent process call identify it as a duplicate message, it will still execute the local integration process. So for example, now let's send the same order again. Now it says again, it has gone to the receiver and the receiver has acknowledged it back saying order was created. Now if you go to the receiver, you can notice it has received these duplicates. That is because we deactivated this skip process call for duplicates. And if you go to the last message, you will notice that even though it's a duplicate message, the local integration process has been triggered, which sends the message to the receiver. So now let's customize our integration flow to get somewhat closer to a real life scenario where we send a meaningful acknowledgement back to the message sender. So when a message comes in, we'll identify whether it's a duplicate or not. If it's not a duplicate, we'll send to the receiver, and the response from the receiver we'll send back to the sender as an acknowledgement. If it's a duplicate message, we will also send a meaningful message back to the message sender saying order with the order number was already processed and will be ignored. Not only that, we will also send a meaningful HTTP response code. You can use something in 4 series to denote it's a bad request. In this example, I will use the HTTP response code 409 to say it's a conflict. Since we have this skip process call for duplicates deactivated, we have to somehow identify whether this is a duplicate or not and send an appropriate response back to the message sender. How we identify whether it's a duplicate or not is through this exchange property parameter camel duplicate message. So after the execution of the idempotent process call, if it's a duplicate message, this will be true. If not, it will be false. So using this camel duplicate message property, we will identify whether this is a duplicate or not and send an appropriate response back to the message sender. Now I have changed my local integration flow to use this parameter and identify using a router whether it's a duplicate or not and take necessary actions. So if it's a duplicate, we know that camel duplicate message will be true. So that is our condition when a duplicate message comes in. So in that case, I am modeling my body of the message as this. So the order number was already processed and will be ignored. This is the response I'm sending back to the message sender. And in other cases where this message is not a duplicate, in that case only I am sending the message to the receiver. Only unique requests, unique orders I'm sending to the receiver. So not only that, when we send the negative acknowledgement where we say the order ID was already processed and will be ignored, we will also send an appropriate HTTP response code back. How we do that is using this camel HTTP response code header parameter. So you can set this parameter with a meaningful value, usually in the 4 series, to denote it was a conflict. So the message sender can easily identify what were the bad requests. Now let us send a unique order ending with 271 to the receiver. We get acknowledgement back. The HTTP response code is 200. And if we go to our receiver, you will notice that that order has come in. And if we try to send the same order again, now we get the response saying order 271 was already processed and also with a meaningful HTTP response code. 409 saying it was a conflict. Of course, you can send unique orders again. The new order was created right here and you cannot send the same order again and again. They are ignored and we are sending a meaningful acknowledgement back to the message sender. Let me activate the trace and show you again. If I send a new order, this is the message. So it comes to the idempotent process call and goes to the local integration process. And now this is not a duplicate message. So the camel duplicate message is not true. And it goes to this path right here and send the order to the receiver. And if I send the same order again, let's see the trace. It comes to the idempotent process call. Since we have the skip process call for duplicates deactivated, it still triggers the local integration process. However, this property right here, camel duplicate message, is now true. So that means it goes on this path and send this response back to the sender with the HTTP response code as 409. So how this idempotent process call identify duplicate messages based on the message ID we provide here is each message that comes to the idempotent process call, these IDs get saved in a idempotent repository in the SAP Integration Suite tenant. Because you have a history of messages that were processed in the repository, when a new message comes in, it checks with the history if that order ID or the message ID was already processed successfully before. If it was processed successfully, it will indicate that it was a duplicate. So these message IDs stored in the idempotent repository are deleted by default after 90 days. So until 90 days, within a period of 90 days, you can do this duplicate check. Now this order ID that I sent just now, today, is in the repository for next 90 days. So within next 90 days, it will be identified as a duplicate message. After 90 days, this ID will be deleted from the repository. Hope you enjoyed the video and learned something new. And if you like the video, leave a thumbs up and also subscribe to my channel. It will help me bring you more videos like this in the future. And if you like to learn SAP Integration Suite, check out my SAP Integration Suite online course. The course has more than 200 video lessons like the one you just watched. And you can see the full syllabus right here. I cover each and every fundamental of interface development with SAP Integration Suite here. And if you like, subscribe. And if you get stuck, of course, if you subscribe, you can ask questions directly from me. I will be there for you to clarify and help you out on your journey. See you on the next one. Bye-bye.